Namaste friends, we are back with lab 4 and in this lab we will be solving problem 12, 13, 14 and 15. So first time we are going to use VS Code because we are going to we are going to do bigger projects which are always not possible with respect to Colab, therefore we are going ahead with VS Code. Fine. So now let's begin this. This is problem 12, program to find maximum of 3 numbers. What we do? We take 3 inputs, number 1, number 2, number 3. This we have discussed. And logic is simple. If number 1 is greater than both number 2 and number 3, then maximum number is number 1. If number 2 is greater than number 1 and number 3, then maximum number is number 2. Otherwise, maximum number is number 3. Now, this is a simpler problem because we have just 3 numbers to find, and here we are just finding out the largest number. So let's look at the logic here. We enter the 3 numbers and we check the number. If number 1 is greater than or equal to number 2, and look at this, number 1 is greater than or equal to, look at this convention sign here, number 3 colon, because this is a if statement, indentation, right? 4 spaces, you remember that, tuck, 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 okay, that is indentation. And then maximum number. So number 1 is greater than number 2 and number 3, maximum number will be number 1. So here this is the statement. Else if number 2 is greater than or equal to number 1 and number 2 is greater than or equal to number 3. Now we are checking number 2 with number 1 and number 3. If number 2 is greater than both of them, therefore here here we are using the operator and here, then maximum number is number 2. So we checked for number 1, we checked for number 2, and if number 1 is not maximum, number 2 is not maximum, what that means is number 3 is maximum, else number 3 is maximum, and we get the output here. The largest number is maximum, that is number 3. Let's run this program. So enter the first number, say enter 100, 100, second number 102, third number 108. Now first it will check if number 1 is greater than number 2. No. Number 1 is 100, number 2 is 102. Condition failed here. It will not even check and num2. This part also will not be checked. Okay. It will come here. Is number 2 greater than number 1? Yes. Number 2 is greater than number 1. And number 2 is greater than number 3? No. Number 2 is 102. It is less than 108. This is failed. Therefore, this is also not executed. By default, that means max number is number 3, that is 108. Okay. So this is problem 12. Let's go to next problem, problem 13. Now this is a program to check if the year is a leap year. We know what is a leap year. Leap year is the year should be divisible by 4. And the another condition is it is not divisible by 100 unless it is also divisible by 400. Right. So this is the condition here. So it should be divisible by 4 and it should be, if it is 100th year, then it should be divisible by 400 as well. And then first we ask for the year, input, enter the year, 4 digit. And then we put the condition here, if year modulus 4 is equal to 0, means it is divisible by 4, and year modulus 100 is not equal to 0, that it is not the 100th year. Matlab 1900, 20th, 1900, 2000, 2000, so that 100th year. Okay. So in that case, yes, the year is leap year. If that 100th year it is, then the year, if it is modulus 400 is equal to 0, matlab usko 400 se fully divisible hai year, then only that year is leap year. Like year 2000 is a leap year. Year 1900 is not a leap year, right? Because it is divisible by 4, but when it is divisible by 100, it is not divisible by 4. That means it is not divisible by 400 and therefore it is not a leap year, right? Maybe you have to reiterate this to understand the logic. Okay. If this condition is true, then what we say, print year is a leap year. Else year is not a leap year. Okay. So let's go ahead. We'll run this code now. enter your year. So I enter year 2024, this year. Now this year is divisible by 4. Yeah, it is divisible by 4. You know divisibility, only last two digits, if they are divisible by 4, the whole number is divisible by 4. And year modulus 100 is not equal to 0. Okay, now what is year modulus 100 in this case? 2024 divided by 100, the remainder will be 24. It is not equal to 0. So this condition is true. Now if this condition is true, the if statement will not check for this also, because it is or. Either this or this true. This is true. We say year is a leap year. Okay, let's take another input now. So let's enter the year 2000. Now year is 2000. Now do the logic. Year is divisible by 4. Now last two digits are 00. That means 100. So it is divisible by 4. If the year divisible by 100 is not equal to 0. Now you divide by 100 and remainder is not equal to 0 modulus. Yeah, this is true. So this has come true. Right? Or divisible year modulus 400 is equal to 0. If you divide 2000 by 400, then it is equal to 0. Yes, true. Then year is leap year. Right. Now let's go to the third condition. Let us check for something else. So we check here now. Let us enter the year. Say 1900. Now 1900 is not a leap year. Got it? Right. So year is divisible by 4. Yes. And if year modulus 100 is not equal to 0. Year modulus 100 is not equal to 0. If now year modulus 100 is not equal to 0, modulus 100 is equal to 0, because 1900 divided by 100, remainder will be 0. So this condition is false. That means this entire condition become false. Okay, let's check for next condition. Or year modulus 400, 1900 divided by 400. So it is not fully divisible, right? 300 will be remainder. Is it equal to 0? No. So neither this is true nor this is true. That means this if statement has gone wrong. No condition is true. Else will be printed, this year is a leap year. Right? So print year, this is a leap year. This is not a leap year. Okay, so this is problem 13. Let's go to problem 14 now. Now here, additional thing that what we are going to check is, we are going to check input validation. Okay. You remember in the hour, minutes, seconds, that problem, what is the angle the hour hand is going to make at 12 o'clock position? We wanted input validation. So now we are introducing input validation here. We want to check whenever a month, day and a year is introduced by the user, inputted by the user, is it a right date? Okay, so this is problem 14. This is a one-line comment. Program to check if date is valid. Input month, day and year. So we will input with month, day and year. So first we input month, then input day and then year. Okay. So month should be between 1 and 12, right? From January to December. Day should be between 1 to 31. That is the maximum. Of course, now certain months will have less number of days, like February. If the year is leap year, then only the month will be having the day of 29. So we have to check for February. So for checking for February, we have to check whether the year is a leap year. So that previous logic, program 13 logic that we have to check, that whether the year is a leap year. If year is a leap year, then 29 is allowed in the case if the month is 2. Okay, so this is the check for February. Also, not all months are 31 days. There are months like April, June, right? September, November. These are the 4 months: April, June, September, November. Which are this month? April means 4th month. June means 6th month. September means 9th month. And November means 11th month. So these months cannot have a date 31 because the maximum date is 30. So we have to check that also. If the month is this 2, 4, 6, 9 and 11, that means April, June, September or November, then the day cannot be greater than 30. If they can be 30, but if it is 31, that is invalid. For these months, there is no date like 31. So we are going to check that as well. This is the checking here. And then if all this is true, we will print the date. It is a valid date. Otherwise, we'll print it is invalid month, invalid day or invalid year, whatever it is, right? So let's go ahead. Here we are going to ask month, day and year. Then we check the month and day are valid. If month is valid, if month is less than 1 or month is greater than 12, that means if it is beyond 1 to 12, either less than 1 means somebody enters 0 or somebody enters -1, -4, or it is greater than 12, somebody enters 15 month, it is invalid. So this is, we will say, invalid month. Okay. If it is between these two, then the control will pass on to the next one and we will check for the date. So first we will check for the month. If the month is not valid, then we will not check for the day. So if month is valid, say, then we come to day. Now what is the day? If first thing is the day cannot be less than 1 and greater than 31, because there are maximum 31 days in a month. So somebody enters 0 as the day, date, divas, okay, day, 0, it is not valid. Or somebody enters -4, -8, it is not valid. So day should be between 1 to 31. Or if somebody enters the day greater than 31, say date, somebody enters the day as 35. There is no 35 date in the month calendar. Maximum is 31. So first check we will do if the day is between 1 to 31. Okay. If day is 1 to 31, then we will say okay, valid है भैया, इसको हम आगे लेकर जाते हैं. We will go to the next statement. If it is invalid, then we will just say invalid date. ठीक है. And if it is invalid date, automatically the whole thing has gone. So now he has entered the month right, that is between 1 to 12, including 1 and including 12. And he has entered 1 to 31 for the day, including 1, including 31. 1 is allowed, 31 is allowed, right? So, and it is entered between them. Now then we have to check for the month of, 5 months we have to check. For the month of February we have to check. If it is a leap year, then it can be maximum 29. If it is a non-leap year, it can be maximum 28. So that we are going to check. And also we have to check for April, June, September, November, because these days only 30 days. Rest all 31 days. Barabar. So now we will check for the month of February. Now look at this. Okay. If month is equal to 2, month is equal to 2 means if the month is February and day is greater than 29, then we have to check whether the year is a leap year, and the entire leap year logic we are going to put it here. And if, this is the leap year logic, what we have exactly studied in program 13. Okay. So if you are not understanding this part of the code, please visit program 13 to understand this part of the code. It should be divisible by 4 and it should be divisible by 100 completely. But if it is 400, then entire logic we have discussed in program 30. Just go 5 minutes back in this video, you will get that entire logic. Okay. So if this is the case, if it is 29, so what we are checking, if the month is leap, the year is a leap year, in that case, look at this, this is year modulus 4, okay, year modulus 4. If the year is a leap year, then 29 is okay, otherwise 28 is okay. And if the day is greater than 29 or 28 on those, then we will say invalid for February. Okay, we'll say invalid for February. So now February we have checked. Now we have to check for April, June, September and November. Okay, now this statement we are going to check April, June, September, November. So we'll check for April. So all these in the month, now look at this, slightly little bit more we are seeing, but this we will be seeing in the after mid-sem when we are going to study the even advanced data structures in data types in Python, like list. So here it is defined as a list. Currently don't worry about what it is, just go ahead that in elif month in this, If the month is any of these 4 and the day is greater than 30, then what will happen? Then print that it is invalid day for the month. So what we are doing here is, if the month is 4 and day is 31, invalid. There is nothing called as 31st April, right? Similarly for June, September and November. So we are checking this check here. Now, and if all these conditions are true, then the default message is, yes, the date is valid, and we will enter day, month and year. Okay, so we'll enter the valid date, right? I'll just explain the logic once again. We are finding out whether a date is a valid date. We will ask for month, day and year. And now we have to do input validation here. For a month, it should be between 1 to 12. So we are checking this here. For a day, it should be between 1 to 31. This is the basic check. If somebody enters 32, it is outrightly out. Okay, if somebody has entered a valid day, then we have to check for February. Either it is 28 or 29. If it is leap year, then 29 is okay. Okay. If it is non-leap year, then only 28 is allowed. In February, if the date is greater than 29, if it is 30 or 31, whether year is leap or non-leap, it is not going to matter. We'll say invalid day for February. So this is being checked here. Okay. Now for other months, April, June, September and November, we have to check the day should not be greater than 30. So this is being checked here. Okay. And if all these conditions are valid, then we'll say the date is valid, day, month and year. Okay, so this is how this entire program is. So let's run this program. We run this. Enter month, we enter 13, which is invalid. Okay, enter day. Now any day you enter doesn't make a difference because month is only invalid. So enter day 25, enter year 2000. Okay, the invalid month. Okay, let's run it once again. And we say enter month, we'll enter month properly. Say 5. Enter day, it is May month. We'll enter a day, and if the day is, say we enter the day of, say 32. There is nothing like 32 May, 32nd May. Okay, 31st is maximum. Okay, and then we say year. What will the message? Correct, invalid day, because there is nothing called as 32. Okay, let's go ahead. We'll enter month, right? So we'll say month is 2, February we are doing. Enter day, we'll enter 30. And it is 2000 year. Again, invalid day because it is beyond 29. February can have maximum 29 or 28. Okay, so it's given correct answer, invalid day for February. So we enter again. So month say 2. Enter date 28. And enter year, we enter 2000. Whether it will be valid or invalid. 2000 is a leap year or not? It is a leap year. Divisible by 400 when it is 100th year. If not clear, visit previous, just go back 10 minutes. Program 13 is all about that. So it is leap year, and leap year can have 28. Yeah, it can have 28. So is it valid or invalid? The date will be valid date. Let's do it once again. Now we will go enter date, enter month, February, enter day 29, enter year 2024, this year. Valid or invalid? We'll check for leap year. Is it leap? Yeah, it is leap. Valid. Date is valid. Now we'll check for some other date also. Okay. Run it again. Enter months. So we'll say April. Enter day 31st. There is nothing called as 31st April. Enter year 2020. Invalid day for the month. Okay. So what they are saying, for this month, April month, you have put a wrong date. 31. Let's do it right now. Enter month. Say we'll go ahead with month of June 6. Enter day 30. Enter year 2000. Says the date is valid. Okay. So we have to very hard check our program. Not that we only do some. We have to really kill the program with very hard check. Right. Very tough conditions we have to give and ensure that our program is right. Okay. So this is an interesting problem. Please rewind the video. And if you have any questions, please put on in the comments. I will have our other students also answering those questions. Okay. Now we go to next program. That is the final program of this lab. And that is problem 15. problem to find roots of a quadratic equation. Okay, what is quadratic equation? Ax square plus bx plus c is called as quadratic equation. It is equation of a curve. Like say somebody is throwing a ball. So when you are throwing a ball, the ball will not go in a straight line. Okay, your force is acting on the ball. Gravity is also acting in the downward direction. So ball will follow a curve, and that is, this curve will be represented by equation like ax square plus bx plus c. Now we want to find out the two roots in this case, right? So here are the example problems. These example problems, solve one and write answer of this in the comments below this video. Okay, what are the answer of this? X square minus 5x plus c plus 6 is equal to 0. This is a quadratic equation. We want to find out the roots. Now how we find out the root is that first we enter the coefficient a, b, c. Okay, this is clear. Here a should be non-zero. Again, we have not put the hygiene condition here. You can put the validation here. If a is 0, we'll ask again a to enter. Just like, we had put this validation here. You can put it here as well. But I have not done that because I want to focus somewhere else. That's why. But you can put the validation here. B and C can have any positive or negative value. That is not a problem. So we got A non-zero, B and C. If A is 0, what happens is it becomes a straight line. Bx plus c is equal to 0. Okay. Then next we'll have only one root. It is not a quadratic equation if A is 0. It's just a straight line, bx plus c. Okay. So that's why we have to see here it is non-zero. You can put in a validation check at this point. Okay. Once we get all the points A, B and C, now we find out discriminant b square minus 4ac. You have learned this in 12th. Okay, b square minus 4ac. Now there are three conditions. If b square minus 4ac is greater than 0, you will have real and distinct roots. What are these roots? Minus b plus minus under root b square minus 4ac upon 2a. That formula. Okay, so we are coming to that formula. What we are seeing is the three conditions for discriminant. If b square minus 4ac is equal to 0, if it is positive, you will have real and distinct root. If it is 0, you will have real and equal roots, right? But if b square minus 4ac is less than 0, then you will have complex roots, and we are not going to calculate here. We'll just say that your roots are complex roots. Okay, so we are getting this a, b and c. We are finding discriminant. What is the discriminant? B square. Now see, look at this, how the b square is written. B star star 2, or you can say b raised to 2. This is also okay. Okay. Or b star star 2. This is also okay. B square minus likha 4ac, 4 multiplied by this multiplication operator star a star c. So this is now b square minus 4ac discriminant. Now I have to check if this is greater than 0. If statement, colon at the end, indentation, tuck 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 tuck. Okay, 4, and only indent the part which you want to run. So this is b square minus. So if this is positive, if the discriminant is positive, then what we say? It is going to have real and distinct root. But what are the roots? Root 1 is minus b plus discriminant b square minus 4ac square root में है वो. So raised to 0.5 बराबर है ना, square root raised to half divided by 2a minus b plus square root of b square minus 4ac divided by 2a बराबर. So this we have done. And what is the second root? Plus minus tha. So if it is plus, here the second root will be minus b minus and the same thing. Okay. So if the discriminant is positive, you will have real and distinct root, and by root 1, root 2. If discriminant is 0, if this is not true, else if we'll check for if discriminant is equal to 0, then we got the real root, equal roots. What is that? Minus b divided by, see, look at this, b square minus 4ac. If this is 0 divided by 2a, so minus b divided by 2a is the root. So this root will repeat, minus b divided by 2a. If discriminant is less than 0, then we just print that the roots are complex. Okay, and now we are going to solve this for these three problems here. Look at this. A is equal to 1, B is equal to -5, C is equal to 6. So 1 minus 5, 6. For this we are going to solve, and then you can solve for other two problems also and write the answers in the comment box. Okay, so let's go ahead. Now we are going to solve for this. 1 minus 5 and 6. Enter A, 1, B, -5, C, 6. Yes, it says, yeah, the roots are real. Now find out what is b square minus 4ac. And there it is positive. That means roots are real and distinct. And what are the roots? 3 and 2. Okay. So now similarly solve other two problems. Write your answers in the comment. If you have any other thing, please write in the comment. And do like this video, share with your friends, because a lot of friends are also going to solve this. And subscribe to this channel. Thank you very much. Have a good day.